students, welcome to the unit number 6, dynamic analysis. In this chapter we need to do the study of types of a dynamic analysis, general dynamic equation of a motion, lump and the consistent masses. What is the meaning of this lump and the consistent mass? Similarly, we need to define the general dynamic equation of the motion. Then we need to define the mass matrices, formulation of a bar, truss and the beam element. Similarly, we need to do the study of the undamped free vibrations, and then we need to resolve these problems with the help of the eigenvalue and the eigenvector concepts. So this is the polynomial technique just to solve the problems of the vibration. So let us move on initials of the dynamic analysis. Now, dynamic analysis, what does it mean? The dynamic analysis, I hope that you already studied the one subject of vibration, and in that vibration you already studied what is meant by the dynamic analysis. So in a vibration we are classifying the dynamic analysis into the three categories. One is called as the modal analysis, second one is the harmonic response analysis, and the third one is called as the transient dynamic analysis. So we are more familiar with the modal analysis because many times we are doing the study of modal analysis, and we are comfortable with the modal analysis a lot time. We are finding the different types of the modes, or many modes we are finding for the structures. Now in this chapter we need to understand the modal analysis in a thorough way, harmonic response analysis in a thorough way, as well as the transient dynamic analysis in a thorough way. In this slide we are focusing on these parameters only. What is the meaning of the modal analysis, what is the meaning of the harmonic analysis, and what is meaning of the transient dynamic analysis. The basic features of the dynamic analysis is that the dynamic loads are either a function of a time or the function of a frequency. Means whenever the loads are applied on the structure or any component or on a part, that time it is a function of a time. It is a function of a time. So if the load is applied with respect to a time, means for it one is not gradually increasing or gradually changing, but it one is impacting like this one. Let us take this is my x-axis and this one is my y-axis. So on this, when the load is applied in this way, so this is the function of a t. So this is the function of a t. This is the t. So if this is the function of a t, then that is called as the dynamic process or the dynamic analysis, or the function of a frequency. Here I mentioned this one is the time. Now instead of that time there is a possibility of the vibrations, or the load is applied in that way. There is a formation of the vibrations, and these vibrations are held responsible for the development of the stresses and the different types of the failures because of the vibration parameters. So these all are doing the study into a dynamic load analysis. So in a nutshell, what is the basic features for the dynamic analysis? The first one, that one is the dynamic loads are either a function of a time or the function of a frequency. Second one, the dynamic load induces a time or a frequency dependent responses. Means what? The dynamic load induces a responses. What that responses are the displacement or the velocities or the acceleration or the stresses are developed into that component. So these are the basic features of the dynamic analysis. What it suggests to us, that just in a dynamic analysis we are considering the loads, dynamic loads, which are the functions of the time as well as the function of a frequency, and which one is inducing a responses called a displacement, velocities, acceleration or the stresses. That is called as the dynamic analysis. Now in this dynamic analysis, the first analysis is called as the modal analysis. This modal analysis playing the very important role in the examination, or even though in day-to-day life also we are focusing on the modal analysis, or even though if you are going for the research papers, then you find there are the more number of the proper research papers available on the modal analysis, and in that one they are finding the different types of the modes for the different structure. we already using different types of the software, and the softwares are given the n number of the modes to the problem, and there is a possibility that you can be able to find the n number of the modes from the problem, but theoretically that is not correct. You need to first of all understand how many modes are possible, and according to that you need to find the mode shapes for the your problems. So let us know what is mean by the modal analysis first of all. So what is the modal analysis? The modal analysis is a undamped free vibration, or it deals with the undamped free vibrations of the structure. Modal analysis is used to determine the natural frequency of the vibration of the structures. So what it indicates? It one is indicating a natural frequency. So because of the modal analysis, you would be able to find out the natural frequency of what? That is of a structure. Those are going through the undamped free vibrations. What does it mean? That you just now let us take there is a something, okay, and this is the mass is applied to that one, and this mass having the load this one, and this one is the fix here. So this one is fixed here, and if I am applying the load of a mass m, then it one is vibrating, and it is freely vibrate. There is no restrictions for this vibration. So what is that? That is called as the free vibration. I feel that there is no need just to focus on the terminology of a vibration system, because you are already going through the subject of the vibrations, and in that one you already studied these all parameters. That's why I am not focusing on all the terminology of the vibration analysis. Instead of that, I am directly moving on that what is meant by the modal analysis. So modal analysis is the undamped free vibrations. What it do? That it deals with the undamped free vibrations of structures. At the same time, modal analysis is used to determine the natural frequency of the vibration of the structure. The governing equation. Now in our FEA subject, there is a need to find out the governing differential equation. So that, or we could say that the stiffness matrix. So here there is a need to find out the stiffness matrices for the masses as well as my stiffness matrix for the K. Hence I need to know first of all my governing differential equation, because this is the first step in a finite element analysis. So the governing differential equation for the modal analysis is a m multiplied by dx square by dt square plus k into x is equal to 0, where m is the mass of the body, k is the stiffness of the body, and the value that mass of a body is in terms of the kg or a Newton, and the stiffness of the body is Newton per meter. So this is my governing differential equation. You later on understanding the importance of this way. Now you need to know first of all what is that governing differential equation. m into that is mass into acceleration, that is dx square upon dt square plus k into x is equal to 0. So this is the governing differential equation for the modal analysis. Now we are moving on the second type of the analysis, that is called as the harmonic response analysis. Now in a harmonic response analysis, we are considering the force vibration. Now in a force vibration, what that? There is a damper we are using. We have already constructed the one diagram, that is there is the spring. This is the spring, and below this spring there is a mass is applying. But at the same time there is a damper also used. So there is a possibility of a damper also used into this system. So this damper also helping to us to control the vibration, That's why the force vibration is, or the harmonic response analysis is used to determine the steady state response of linear structure subjected to periodic force, which is frequency dependent, or this is called as the force vibration. Now the governing differential equation, or again I want to explain this one in detail, that is harmonic response analysis is also considered as the force vibration process, is used for to determine the steady state response of a linear structures subjected to the periodic force, which is frequency dependent, not the time dependent, that is called as the force vibration, example is that the vibration of the IC engine. Again the differential equation, governing differential equation for the harmonic response analysis, that is the mass multiplied by dx square by dt square plus dx by dt plus kx is equal to f. Now you see the difference here, that here there are the three terms, here there are the three terms, while in a modal analysis there are only two terms, that is the mx double dot plus cx dot plus kx. So this term is not available into the modal analysis, while in a harmonic response analysis this term is available. Now what is the meaning of this one? M is the mass, C is the damping coefficient, so I have already constructed the diagram, and in that diagram I have mentioned that there is a damper is available. So when the damper is available, so effect of damper is included into the differential equation, and that one is writing here. So m double dot x plus c single dot x plus kx is equal to f. This is my governing differential equation for harmonic response analysis. So k is again the stiffness matrix, and f is the harmonic force. So this is my harmonic response analysis. What is the difference between the modal and harmonic response analysis is that one, in a modal there are only two terms, that is this mx and the kx, while there is an addition of the cx into a harmonic response analysis. Let us move on a third terminology, that is the transient dynamic analysis. So we have seen now there is a steady force, okay, then undamped force, then the force vibration. Now there is a process of the damped free or the force. Now let us move on. The transient dynamic analysis is used to determine the response of a linear structure subjected to non-periodic sudden loads. Now in a modal analysis, what we suggest in a modal analysis we are suggesting that undamped free vibration, but here we are consider that there is a steady state process. Means there is no sudden impact or the sudden parameters are available, while in a harmonic response that is the subjected to the periodic forces, while in a transient dynamic analysis there is a non-periodic and sudden load. What does it mean? The mean is that when the force is the possible, not in a systematic way, but instead of that there is a possibility of force nature is like this one. So what is that? Non-periodic. So it one is not showing any periodicity, as well as there is the sudden loads. Means see all of a sudden there is a large force is applied, or all of a sudden less force is changing, or the nature of the force is changing. So whenever we are doing such type of the analysis, that is called as the transient dynamic analysis. So I hope you are understanding a very simple way, a three type of the responses we are doing the study into the dynamic analysis. What is that? The first one, that is the modal analysis. Second one is the harmonic response analysis, and third one is the transient dynamic analysis. What is that? The modal analysis, the very important one, that is undamped free vibration. So there is no damper is using, and hence the governing differential equation is m into x double dot plus k into x is equal to 0. While in a harmonic response analysis, that is the damper is used. That's why the role of a damper is available into a governing differential equation, that is the c into x dot. And the last one, that is the that is the transient dynamic analysis. So this is the non-periodic and the sudden load. This is not included into our syllabus, that's why just I am telling you about the what is mean by the transient dynamic analysis. Thank you for watching the video number 1 for unit 6.